Now the luminosity is basically how much the total power output of a body is. And we can give the luminosity the symbol L, and this basically tells us the total amount of energy emitted per second. Now in the case of stars, what we find is that the total brightness of that star, how much energy it's giving out per second, is proportional to r squared. So effectively, if you have stars which have a bigger diameter, a bigger radius, they give out more energy. And in actual fact, this is proportional to 4 pi r squared, because 4 pi r squared is to do with the surface area of a sphere. So basically what we can say is that the luminosity is proportional to the surface area of a star. The other thing is that this luminosity is proportional to the temperature, but it's not just that you double the temperature and the luminosity goes up, it's actually proportional to, L is proportional to T to the power of 4. And this is the surface temperature of that star. And you've got to remember that the surface atmosphere might be at maybe 40,000 Kelvin if it's a particularly hot star, or maybe something about 6,000 Kelvin if it's something like our sun. It's not the temperature in the middle where fusion is going on. So we can sort of combine these two things together to say that the luminosity is proportional to 4 pi r squared T to the power of 4. And if it only depends on these two factors, we can then put in our constant of proportionality. And the constant is this symbol down here. This is a sigma. And this stands for Stefan's constant. And basically the Stefan constant has a value of 5.67 times 10 to the minus 8. And then the units are watts per square metre to Kelvin to the minus 4. And basically this means you can actually work out various things about a star just by knowing its temperature. So what this means is perhaps as an astronomer you look up into the night sky. What you can then do is maybe look at what colour that star appears to be, and you can then work out the maximum wavelength of emitted light. Now I know by Venus displacement law that this is proportional to 1 over the temperature. So if you know what colour the star is, it means you know what temperature is. If you also know how bright that star appears to be, you then maybe know things like the luminosity. And if you know the luminosity and the temperature of the star, then this means that you can then work out things like the radius of the star. And once you know things like the radius of the star, you can then work out things about like the mass of the star and how heavy it might be. So basically, just by looking at starlight, by analysing it, just by just observing it, about what colour the star appears to be and how bright it appears to be, we can do all sorts of other things where actually work out how big the star is and how hot it is. And that's why these laws are quite useful. So I hope that makes sense, and I'm going to explain a bit more about starlight in my next video.